Okay, I think we're going to get started here. We're still waiting for people to come, but I just wanted to show you a few things, and students miss this at the beginning. They can look at it on the recorded version. So first of all, right, there's been some people saying on the 7.1 homework that they've had some issues with it, and so I just wanted to make sure that you know that if you are having some kind of issues with it, just let me know. Some people are saying like this first box sometimes is always marked wrong no matter what, but on other students aren't having that problem, so I'm not quite sure why that's happening. But if you're getting everything correct on here, there's just for some reason this top left box is going red and it's not giving you the point for that one, then just let me know. And one thing that I know when I looked at the answers, it has the x's going from -2, -1, 0, 1, and 2, and that shouldn't matter. That order shouldn't matter, but sometimes little things like that will make a difference. But anyway, but that might not work for all of you, but sometimes you can just, if you've missed it or whatever, go down and look at the answer and see what's happening, because they'll kind of talk you through some of it. So remember to do that also, and just make sure that that's, something that you've been trying to do. If you're getting frustrated on some of the homework, that might help a little bit there. Okay. Any other questions on 7.1 homework that you wanted to talk about?
Can you hear me?
Yeah.
Okay. I don't know if anybody else feels this way, but I wasn't sure that we had gone over everything that was on that particular homework.
No, and you're right, we hadn't. I was really hoping we'd get through 7.1 and 7.2 yesterday, and the homeworks kind of overlap a little bit there. So, but we'll start in. You'll be able to get the rest of it completed for sure after we talk today. So thank you for bringing that up for sure. All right. Let's see. And then maybe just a couple of other reminders. So the test, exam 2, is due tonight by midnight. And so make sure that you're getting that done and in. And remember, with anything in this class now, like if you don't have a printer, you don't have to print things off. You can just write things out on hand, on lined paper, take a picture of that and upload it to me. That will be just fine. So, so don't worry about that. If that's, you're like, I don't have a printer, Becky, and that's okay. So, but just make sure that however you complete the test, that you use one of those photo to PDF converters, just because usually photos, they're really hard to read on my end, and so the PDF converter just makes it so much easier for me to be able to see what you have written. So keep that in mind, and if you're having issues with that, let me know, and make sure you let me know today, since the test is due tonight. So make sure you're not waiting too late in the evening to ask me for some help if you need some help on that. Okay.
Are you wanting us writing out the questions as well, or just the answers?
I just need to see your work on it. So not just the answers, but you don't have to write out like the whole question, especially if it's like a story problem or something like that. But if it's just, solve this, graph this, or whatever, make sure you're just doing what it's saying there. But and then just be really careful on the graphing part too, if you're doing it on your own paper, just to make sure that it's legible and stuff. So on that graph, and that it's readable. And that's really for anybody. Just make sure it all is legible and readable and stuff like that. And if you need to work things out on another sheet of paper first or whatever, and then, transfer things over, that's fine as well. Whatever works for you there, but just make sure I can read it. Okay, and then also the car comparison project, it's due tonight, but I gave you a little bit of leeway and I'll accept it until April 2nd, because I know, having the test due tonight, having the car comparison project due tonight, might be a lot. So I'd say make sure you're focusing on the test today, get that done, get that into me, and then you'll still have a couple of days to work on that car comparison project. Okay? Any questions on any of those just little matters like that?
What was the name of the website for the graph on the car comparison stuff?
GeoGebra.
Okay, that's right. I know I have it written down somewhere, but...
Yeah. So, GeoGebra, that's what you'd be using. Let that go. Okay. Let's see what happened here. All right. So open up your books. We're going to be talking about. We're going to be on the 7.2. We're going to do something a little bit different than what it's talking about here. I want to kind of show you another thing that we're going to do with this, but I want you to write your stuff down on here. It'll be easier. Just close these things up. Okay. Let's see here. All right, so before we get started too much into this, I want to just kind of talk to you a little bit about, I want you to think of, I know you hear me say this a lot, that, math is kind of like a game, and I want you to kind of think of it as a game, and, and so we're going to do a little something here where there is a little game on, what we're doing and stuff. So, let's see here. So, let's start off by making sure everybody's muted, right? I think everybody's kind of getting used to that. And then I'm going to be asking some questions. So you're muted if your microphone is red on the side by the participants box, right? That means it's muted. But I'm going to ask you some questions, and I want you to raise your hand when you have an answer to it. So I can call on you so we don't have everybody calling out at the same time. But this is going to kind of help us with what we're going to be talking about the next little bit. So I want you to think about a number that multiplies to be 8 but adds to be 6. So what numbers multiply to be 8 but add to be 6? Let's see if I can. All right. So Peter, what did you come up with? 2 and 4. Say that again. 2 and 4. 2 and 4, right? So 2 and 4, if you do 4 times 2, that's 8. If you do 4 plus 2, that's 6. All right, so this is kind of like the little game that I'm talking about here that we're going to be doing. It's just like a little number game. All right, so what multiplies to be 18 and adds to be 11? Multiplies to be 18 and adds to be 11. Rachel?
9 and 2.
9 and 2. Okay, so if you do 9 times 2, you get 18. 9 plus 2, you get 11. All right, what multiplies to be negative 24 that adds to be a positive 2? So what multiplies to be negative 24 that adds to be a positive 2? Nikki? Let's see, I don't hear you, Nikki. Do you say something?
Is it -4 and 6?
Yeah, -4 and +6. All right, so -4 times 6 is -24, but then -4 plus 6 is a +2. All right, and it doesn't matter which order we put those in, right? Because multiplication is commutative and addition is commutative. So it doesn't matter which order we put those in. So that's something to keep in mind for what we're going to be doing also. Okay, what about what multiplies to be 40 and adds to be -13? So multiplies to be +40, but adds to be -13. Luciana?
Sorry, I had my hand raised from previously.
Oh, that's okay. All right. Do you want to keep thinking about it? So what multiplies to be 40 that adds to be -13? Keep thinking. Let's see. We've got Michael. What do you think? Can't hear you, Michael. Did you unmute yourself? Okay, Luciana, why don't you try again?
So I got -5 and -8.
Yeah, right? -5, -8. So when you're trying to figure this one out, that one's kind of maybe a little bit harder to think, but in your mind, you might want to start, thinking about, okay, what things multiply to be 40? And then you got to keep in mind that two negatives make a positive also. So you've got the negative numbers that you could be thinking about as well there. And so -8 times -5 gives you +40, but -8 plus a -5 gives you -13. Okay. How about this one? What multiplies to be -56 and adds to be -1? What multiplies to be -56 and adds to be -1? All right, Michael, hand went up again.
Yeah, -8 and 7.
Yeah, so -8, right, times 7 gives you a -56, and -8 plus 7 gives you a -1. So sometimes those get a little bit tricky when it's saying, okay, what adds to be like a -1 or something. Sometimes people get kind of stumped on those, okay? But I want to talk about this problem that's written right up here at the top then. So we're basically trying to factor this. And so when we're trying to play the game with this, first of all, this game that I'm doing only works if the leading coefficient is 1. And we'll talk about what to do if the leading coefficient is something other than 1, right? But you want to make sure you have these in descending order. And so when you have them in descending order, you're going to have the x squared, then the x, and then the whole number. And so you're thinking to yourself, what multiplies to be this last number, okay? So we're thinking what multiplies to be 6 and then adds to be the middle number. All right, so in this one we're thinking what multiplies to be 6 that adds to be 5. So, and some of you might know this right off, but not everybody's hands were going up, so it was hard for me to tell if people were understanding how you were coming up with this. So let me just explain a little bit. It's easiest on this if you're starting with the multiply. So list things out in an organized manner. So when you're figuring out what multiplies to be a certain number, right, then we're saying, okay, I'm going to have, I know 1 times 6, right, is 6, and I know 2 times 3 is 6. These dots going away. right? And then I also have, 6 times 1 and 3 times 2, but again, it doesn't matter because those are just, commutative. So we can have those in either order. But now, right, we're looking at this. Which one of these, there's only one pair of these that would add to be 5. And that would have to be this one because these are both positive, right? So a positive 2 and a positive 3. Right? We could have written down some of the negative things too, but sometimes it's easier to just write them down, without the negatives, meaning that if I did -1 times a -6, right, that's also a positive 6, and a -2 times a -3 also is a positive 6, right? But the only ones that will add up to be a positive 5 is 2 and 3. And so this is kind of the little thing that we're going to be doing when we're trying to factor these trinomials. So what you're going to do, so factors, remember, mean you have something times something else. So, and what they equal is the product, but the two numbers or two things being multiplied together are the factors, right? So this is a factor and this is a factor. Right? And so if I look at the very first term, I've got, what times what is x squared? Well, that's x times x. And then what times what is 6? That adds to be 5. And we decided that was a positive 2 and a positive 3. And so this would be our answer. This would be that in factored form. Right? And that's going to be easier for us with what we were talking about last time. Remember how some of our equations were already in that factored form? And so on your homework, you're going to be asked to put some of them in this factored form, is what you're going to end up doing a lot of the time on this. Okay. What questions can I answer about just how we're doing this type of factoring? We'll get to other types too, but I want to make sure that this one is making sense to everybody first. All right. And Michael, your hand's still up if you want to put that down, unless you had a question. I think it was up from before. All right, and then make sure, again, make sure everybody is muted. I know it's going to be kind of hard to get used to that, but sometimes we get weird feedback and stuff when you're unmuted. So, but I still want you to be, I want your participation and everything too. Just, click on the unmute to talk and stuff too, because I really want that. So let's look at a few of these on the next page. So turn to the next page. Let's see. So let's turn to the next page, and then I want you to try and do this first one, because we need to talk about some things in the other ones. But go ahead and try and do part A on there, with what we just talked about. All right, so somebody tell me what you came up with when you factored this. The whole thing, not just the numbers, but tell me what's in each set of parentheses. So raise your hand if you have that figured out. All right, Haley, what did you come up with?
I have x plus 2. And then x minus 9.
Hey, is that what everybody got? Thinking what multiplies to be negative 18. So she's saying 2 times negative 9. That looks good, right? And then what adds to be the negative 7? Well, she's saying that that would be, so just like that, that will be 2 plus a negative 7. Or sorry, 2 plus a negative 9, which gives us negative 7. All right. Okay, so that's your answer right there. That's it in factored form. That is what we were doing. Okay, but then look at C. I want to do C next. So one of the things that you need to look for on these is a GCF, meaning is there a greatest common factor that I can see in each of these terms? Because if there is, I always want to factor out that GCF very first. Okay, so I'm going to put that up here. Factor out GCF first. Okay, so that is something that is really important. Look for that GCF. Not all of them will have it, like Part A didn't have a GCF, but this one does. Okay, and if the leading coefficient is negative, then we're going to want to factor out that negative along with it. So meaning, yes, 5 divides into all of these numbers, but negative 5 does also. And we want this leading coefficient to be a positive number. It'll just make it easier for us to do our factoring. So I'm going to say on here, so my GCF is negative 5, right? Because negative 5 divides into negative 5, it divides into 10, it divides into 15. I'm thinking, what's the biggest number that will divide into all 3 of those numbers? Right? That's that greatest common factor. And so if I factor out that negative 5, then what's left, right, because I'm really like dividing each of these parts by negative 5. So I'm going to actually, sometimes for some students it's easier to see if I write it like that. So I'm doing, okay, I'm dividing each side, or sorry, each part by a negative 5. So when I do this, negative 5 divided by negative 5 just leaves me x squared. Right? And then the second one, if I do 10 divided by negative 5, that's going to leave me a negative 2x. Don't forget about our x there. And then 15 divided by negative 5 is a negative 3. Okay. All right. What questions do you have on that?
So whatever you're dividing by is what you leave outside the parentheses?
Exactly. That's exactly right.
Or whatever.
Uh-huh. So whatever our greatest common factor is on the outside. Because notice, we're basically, factoring is just undoing multiplying. And we talked about multiplying a little while ago. And so if we were to distribute this negative 5 back through, we'd be back to where we started, right? So we're just undoing that process. So yeah. And then we can look and see if we can take this further, because now look at, this is a trinomial where the leading coefficient is 1, kind of like we had over here on part A. All right, so now we're going to keep that negative 5. That's still part of our answer, but we want to see if this will factor even further. So we're going to say what multiplies to be negative 3, right, that adds to be negative 2. Okay, so what multiplies to be negative 3 but adds to be negative 2. Anybody have an idea there what we would do?
1.
Okay, so Leah, what do you think?
I got negative 3 and 1.
So negative 3 times positive 1?
Yeah.
Right? Multiplies to be negative 3, and then negative 3 plus 1 adds to be that negative 2. So yeah, so when you're putting it inside your parentheses here, right, we'll have our x's, because remember the first part, x squared, x times x is x squared, and then what times what is negative 3 that adds to be negative 2. So that's going to be a negative 3 and a positive 1. And it doesn't matter which order you write this in, meaning, you know, sometimes students are saying, well, what if I wrote it as negative 5 times x plus 1 times x minus 3? Well, these are all connected by multiplication, so it doesn't matter which order you're putting it in, right? Just make sure that you understand that. And there's not even a preferred order. You know, sometimes in math we say, oh, we do things this way just because it's tradition. There's not even a preferred order. Either one of these is great for your answers. Okay? Okay, what questions can I answer on that one, where we had that greatest common factor? Nothing? Okay, so now I want to talk about what happens when we look at something like B, right? And we look to see if there's a greatest common factor. So I see that 2 is my coefficient on the first one, so I'd want to see, does 2 divide into all of these numbers? And it doesn't, so that means there's not a greatest common factor that can come out. So this one is a little bit different in the way that we need to go ahead and work it. And so sometimes it takes a little practice, a little more practice if the leading coefficient is something other than 1. But I'm going to show you a few different ways that you can do this, and you can just pick which way you think works best for your brain, all right? So first off, and in either method, the first thing you're going to do is when you have a leading coefficient of something other than 1, I want you to multiply the first and last term together. So I'm going to, and by that I just mean the number in front of it, right? So you're going to do the 2 times the 10, and so that gives you 20. Now this becomes the number that you're trying to see. What multiplies to be 20 but adds to be 9, right? So that middle term still stays as our what adds to be this number. But when there's a leading coefficient there, right, something other than 1, we've got to multiply those together. Because really that's what we were still doing on this one up here. We were doing 1 times negative 18 gave us the negative 18, right? It just didn't change that number. So that's what we need to remember to do on this type. Okay, and then, so what can you think of now? So what multiplies to be 20 that adds to be 9? Somebody ring in. Let's see. What do you guys think here? Raise your hand. Tell me what you think there. What multiplies to be 20 adds to be 9? Let's look at it. Rachel, what do you think?
4 and 5.
Okay, 4 and 5. And you can't go straight to the parentheses like we did before when the leading coefficient was 1. So there's going to be something else that we have to do here. So one thing that I want you to think of here is we could make this trinomial into a 4-term polynomial. And that's going to help us do like the box method, like we talked about before when we were multiplying these binomials together. Now we're just undoing that. And so I want to show you the box method, but the box method you have to have 4 terms here. So instead of the 9x in the middle, we're going to break that down and put a 4x and a 5x, because 4x plus 5x gives us that 9x. So let me do that here. So I'm just going to show how we're going to kind of break this down into a 4x plus a 5x. All right, that will give us the 9x in the middle. But we still have that 2x squared plus, and then the plus 10 at the end. So let me stop right there a second, because sometimes this is where people get a little bit confused. So we're trying to make this trinomial into a 4-term polynomial. Right? And we did that just kind of by the same method we were doing before, but now we need to remember to take the leading coefficient and multiply it by that last term. So we got 20. What multiplies to be 20 that adds to be 9 was positive 4 and positive 5. Okay. And then you're going to split this in it down the middle here. So there's kind of a little, I'm trying to put a little dotted line here. Sometimes don't look quite. But that's like my little dotted line there. So I'm splitting this up, and basically I'm just looking at these first two terms, and I'm going to do stuff with that, and then the second two terms, I'm going to do something with that. Okay? And so this is one way that you can do it, and this is called factor by grouping when we're doing it this way. So if I split it up, and then I'm looking at these first two terms, and what's a greatest common factor that goes into both 2 and 4? Well, 2 goes into both 2 and 4, so 2 goes on the outside, and then if I divide both of those terms by 2, I get x squared plus 2. All right, sorry, I meant to take out a 2x, and I didn't put that x on the outside. Let me just, never seem to, I'm just going to do it this way. Okay, so let's take the 2x, right, because there's an x in both of those terms, so that needs to be part of our greatest common factor. It won't always just be a number. And then that leaves me with just x plus 2. All right, so if I distributed that 2x back through, right, do you see how I'd end up with 2x squared and then 4x? Right, but I'm just dividing both of those by a 2x. Right, and then I'm going to do kind of the same thing over here, but now think about what's the greatest common factor with 5x and 10. Well, 5 will divide into both of those. And since this is a positive 5, right, then we will divide out a positive 5 there. But if this term was negative, we'd want to divide that negative out with it. And we'll do some like that to see what I mean. But kind of like when I was talking about, you know, this leading term up here, we want that to be positive, so we divided that out by a negative 5. Well, this kind of becomes the leading term of this part, so that's why we want to do the same thing there. So if I take out a 5, right, divide out a 5, then I'm left with x plus 2. And now I can see, all right, so I've got something that is in common with both of these. I can see I have an x plus 2 and an x plus 2. So that is a greatest common factor now that we're going to divide out of both of those. So x plus 2, oops, I'm going to use a different one. So x plus 2 is going to be in one of the parentheses because that is the greatest common factor of those two things. And then these guys that I kind of put the squiggly lines underneath are our leftovers, and those are going to go into the other parentheses. So I get 2x plus 5. Okay. And so that's my answer, right? But if I wanted to check it, I could do what we were doing before when we talked about FOIL, right? And how I'm just distributing, you know, each of those things through. So let me just do that on this one just to show you. So if you wanted to check it, right, you do x times 2x gives me 2x squared. X times 5 is 5x. And then 2 times 2x is 4x. And then 2 times 5 is 10. And then if I combine those middle two terms together, I see that I ended up with what I started with here, right? What my question was. So I know that's right because factoring and multiplying these together are actually opposite operations. So that's what I need to remember there. Okay, so this is one way that you can do it. But a lot of people, you know, I mean, some people like this way. Other people like to go from this. I'm going to write this out in purple again and show you. If we start from here again, so if I have my 2x squared plus 4x plus 5x plus 10, and instead of doing this factor by grouping, I'm going to undo, remember when we did like the little box method before? If I'm going to undo this, then I need to put, so I'm trying to figure out what these factor into. So last time we had the numbers on the outside and then we multiplied them together to see what it gave us inside. But now we're doing it just opposite. So I'm going to put my 4 terms inside these 4 boxes. So I'm going to have my 2x squared, my 4x, my 5x, and my 10. Okay. And then I just want to look at this, and I'm trying to undo this, undo the operation. So I'm looking, let's just look at this row, okay, this row first. So I'm thinking, what are the common factors of 2x squared and 4x? Well, that's 2x, right? 2x can divide into 2x squared, 2x can divide into 4x, right? So I want to try and find that greatest common factor. Do the same thing down here. What divides into 5x and 10? Greatest common factor there is a 5. Right? And then I want to look the other way too. I need to look on my my columns also. So if I'm looking here on this column, so 2x squared and 5x, right? What do those have in common? Well, it looks like just an x, right? A 2 can't divide into both of those, an x squared can't, but each of them have an x in common. So an x is the greatest common factor there. And then on this one, we got the 4x and the 10, and 2 is the greatest common factor of those two. And since this was a positive 2 we were taking out, we'll put a plus there. And then it was also a positive 5 that we divided out of those, so we'll put a plus there. And now I can see, oh, I've got my answer now. So in one of my parentheses, I'll have that 2x plus 5. And then in my other parenthesis, I'll have that x plus 2. Okay, let me stop there a second. I feel like I've just been talking so much, and usually I'd be asking you guys more questions on this, and I want to make sure you're understanding. So what questions can I answer here on this? Nikki?
It seems like you skipped the second one doing box is way easier. I don't know, is that true? Or is it, in the end, is it still like just the same amount of work?
It just depends on, like I said, some people prefer this first way I showed it. Some people prefer the second way. It just is preference more than anything. In the end, you're probably doing the same amount of work, but usually for some people, one way makes more sense than the other. Is that clear? So you can pick either of those 2 ways. And I'm going to show you one other way that you can do this as well. And some people like this way also, but you've just got to just kind of play around and figure out what makes the most sense to you. Because there's a lot of different ways that we could, that we can do these, but I want you to find a way that works for you. Okay, so this first one over here was called factor by grouping. Then the second way is called the box method. And I'll do this part D somewhere else. I'm just trying to make sure that I can show you all of these different methods in one. But this last method is called synthetic factoring. And synthetic factoring is probably the fastest way, but to some students, it just doesn't click with them, and that's fine. Like if it's not working for you, don't use it. Like find a way that you like and that works for you. Okay, with the synthetic factoring, you still are going to kind of start off with what we, had here, but I'm going to kind of go back to what I have in red. So we were thinking, okay, what multiplies to be 20, right, that adds to be 9. So we're still going back to that. We still have to multiply, right, the first and last term together to get that 20, and then think, okay, what makes it add to be that middle number in this case is 9. All right, and so with the synthetic factoring, there's going to be, we said that it's 4 and 5, right? So I'm going to take it to that. So we're going to have 4 and 5. But instead of kind of breaking it down and stuff, we're actually going to make these into some fractions. And so let me show you what I mean here. So 4 and 5 become the denominators. And so then, let me see, I'm trying to do some different colors to hopefully make sure this makes sense. So those are the denominators of these fractions that I'm looking at. And then that leading coefficient from what we started off with was a 2. And that 2 is going to go at the top on both of these fractions. Right? So I had to take that leading coefficient right there. Maybe I'll write this out again here above it. So I was just taking this, and actually this top is going to be where my x's are at. So the top part of the fraction is my x. So some students find it a little bit more helpful to put those x's there on top. Okay? And then what you're doing from here is just reducing fractions if there's anything that can be reduced. So I can see on this first fraction, right, that 2 will divide into itself one time and into 4 twice. And then the second fraction, there's nothing there that can be reduced. So right off the bat now I have my answer. So once I have these in reduced form, then I'm saying this first fraction is making my first factor. And since it's a positive 2 there on the bottom, right, this is x plus 2. So that fraction becomes the x plus 2. And then this other fraction, maybe I'll kind of point to it, make sure. And then this other fraction becomes my other factor. So 2x, and again I have a positive 5 on the bottom, so plus 5. And that becomes that part. So all three ways I came up with the same answer, right? And it doesn't matter which factor is written first and which one's written second, but I can see that I can get to this factoring any of these three ways. Okay? Okay, what questions do you have on that last one? Because I know that one's kind of a little bit different. And some of you might want to start off with one of these two methods, the factor by grouping or the box method. And then as as we go on and stuff, sometimes the synthetic factoring makes a little bit more sense and you're like, oh, okay, I see what Becky was talking about before. But like I said, it doesn't matter which method you use. This one becomes the fastest overall, but if you're doing it fast and it's wrong, that doesn't really matter, right? So choose a method that works best for you. Okay. All right. Were there any questions? I'm trying to watch the hands and stuff. Okay, I want to look at one other one. Well, let's see, part D. I need to go back up. Part D is a little bit lost there in what I just did, so let me move it up here. So part D, it wants me to factor x squared minus 16. And so on something like this, you could still think to yourself, like, do you see how the middle term is not there? We could write it down as like a 0x, but not really necessary to do that. But there's no middle term, right? Or that middle term is 0. So really on this, so I'm noticing, okay, my leading coefficient's 1. So again, I can go to what I was talking about to start off with. So what multiplies to be negative 16, right? But adds to be 0 because I don't have a middle term. That middle term is 0. So what do you guys think of there? What two numbers would multiply to be negative 16, but when I add them together, I'd get 0? Okay, Rebecca, what do you think?
-4 and +4?
Yeah. Somebody see that? So if I do -4 and +4, if I multiply those together, I get -16, but when I add them, I get 0. So when I put that in the parentheses, right, then I'll have x minus 4 and x plus 4. And that would be my factored answer. And if I, distributed that back through, did the FOIL, then I would see I would come back out with this, because the middle terms, right, will cancel each other out, because I'll get a -4x and a +4x. And so that's why I get that 0 there in the middle, because those are opposites of each other, and so they're canceling each other out there. Okay. So you can look at it that way with this. I want to, let's see, let's try having you do these two. I know they look a little bit different, but I want you to try it on this, right? On this first one, you'll notice that there's not 3 terms here, right? Or on part B, but you want to start off with the GCF, right? So figure out what's the greatest common factor that could come out of both of those, and then what's left. Okay, so go ahead and let me give you a few minutes. Try and do those 2 problems. And then when you have them done, if you'll raise your hand, just so I know I'm able to do them. Something's really going wrong with my thing here. All right, so will somebody say what you came up with on part A? And I need to try and close this down and get back into it. But if some of you can do that, that would be great. All right, go ahead and do you feel like you can do that? Braxton, did you?
On part A?
Yeah, on part A.
So I just like divided or took out the 6x on the outside and then like divided those like the 6x squared and got x minus 2. So it's 6x parenthesis x minus 2.
Okay, so 6x and then parentheses x minus 2. Is that what everybody came up with? That sounds good. Okay, what about on part B? Let me try that one. All right, just go ahead. Just somebody, sorry, I'm trying to get this to shut down because it has stopped working. I've got to try and get out of it, but it's not wanting to listen to me. So if you just go ahead and start talking, whoever.
I got negative 5x times x minus 8.
Okay, times x minus 8. Is that what everybody got? Because when you're dividing both, if you go to your Canvas page, I just want to make sure you know where to find some things. So if we go into the modules, all right, and we're in module 7 right now. So notice that I have that class recording from last time that's here. And so today I'll put a class recording in down further. So if you're trying to look for those class recordings, I'm just putting them right inside the module. Hopefully that will be the easiest place to find them. But there's a few things that you're going to be needing to do some worksheets and stuff on. So notice on 7.2 there's actually not going to be anything on Edfinity. Just trying to make sure, but there's other thing that you're going to be doing. So one is a little factoring activity, and just to try and help your fluency, because really pretty much like being able to do this, factoring pretty quick and stuff is going to be something that is helpful for you. Sorry, I am not sharing my screen anymore. I forgot that. So you guys are like, what are you talking about? Sorry. Let me go back. So, so when you're in our modules, right, on module 7, right, so these are the things, like I said, this was the recording from last time, and then the homework, and then 7.2 has a few different things here. So this factoring activity is just kind of a little, like, I don't know, like Who Wants to Be a Millionaire kind of game, where, you need to, keep going up the ladder here on this. And so on the directions they say, you need to get to at least 32,000. But if you get up to 1 million, then I'll be giving you some extra credit on there. So because if you do this, right, so this is going to be the x plus 7, x plus 2. But then say on this one, I miss it and I choose like this one, then it's going to take me back to the bottom again. So, so if you're missing one, so that's why you're just going to be really careful as you're going through and doing that and get up to that 32,000. So that's one of the things that you're going to do for our 7.2 homework. But then also there's going to be this practice with factoring worksheet. And let's see, I already pulled that up. And so it's going to look like this. And again, you don't have to print this out or anything. You can do this on, you know, just a sheet of paper and then upload it here to this, you know, to this page, or, you know, to where this assignment is at. So there's some right here that have a leading coefficient of 1, some that don't, and so you're just going to have to kind of, you know, work through those and see that. We haven't talked yet about 11 through 17 yet, but that's what we're going to do next. So I'm hoping that we can kind of get through some of that, so you'll see how to do the rest of that worksheet. So really this has kind of, you know, 7.2 and 7.3 on it. And then, let's see. And then there's also something that we're going to talk about, which is called this special factoring. And so I want to go in and talk about this special factoring next, and then there's a special factoring worksheet that you're going to be doing with it. All right, so there's nothing on Infinity that you're going to be doing for 7.2, but there's all these other like worksheets and activities that you need to do. And factoring is probably the most important thing that you learn, that you'll need in your next math classes. Like I said, it's kind of, you know, I mean, getting it down, making sure you're kind of like fluent with it, and really that just takes practice. And so that's why I'm trying to give you these practices and things that you can do there on that. Okay. So let's look at, I'm going to pull up this, you can look at the special factoring notes. Let's see if it'll let me just write right on here again. Hopefully it will. Might not yet. Sorry, I had everything pulled up behind and then I had to close it all. So these are some special factoring rules and some things that you're going to need to know. Ugh. Pull it up this way and see if it'll allow me. Oh, I'm getting so flustered. I'm sorry. I just hate it when things go wrong on these things. It just takes so much time. I don't want to have to be doing this. Okay, so looking at some of these special factoring rules, and like I said, these notes are right in your in there, but we're going to be filling things in on this. Okay, so one of the first things that we're going to be talking about here is this, it's the difference of two squares. Okay, of course that's missing now. All right, so we've got these difference of two squares. So if you have something squared minus something else squared, right, then that's going to factor to be this a plus b times a minus b. So we just did one kind of like that where it was the x squared minus 16, right? So we did this kind of part b already in our notes. So when we don't have that middle term, but we notice that our first term could be written as something squared and our last term could be written as something squared, right? So meaning if I rewrote this out, do that every time. Gosh. All right, I might have to go to something else here. This is just causing me some craziness here. All right, I'm going to use this to write on. Maybe. Okay. I'll have to write over here then instead because it's not working. All right, so yeah, so this is a difference of two squares. So notice like on part A, I could rewrite that as x squared minus 3 squared, right? Because 9 is a perfect square. And so then when I go to factor something like that, right, then this is where I'm going to have in one parenthesis x plus 3, and in the other parenthesis x minus 3. So whatever that, squared term is there, is the number that's going to be going inside those parentheses. So basically it's just kind of like a little shortcut if you recognize these as being two differences of squares. Okay. And then there's something else called sum and differences of cubes. And so this one, so if we're looking at this here, and these two things you're going to need to get memorized. Okay, so I want you to write down this a cubed plus b cubed equals, and when you have something cubed plus something cubed, it's always going to be factored in the same way. And so in the first parenthesis, we'll have a plus b. In the second parenthesis, a squared minus ab plus b squared. So and I want to do an example with you to help you see what we mean by this. But it's going to be best to put these in terms of something cubed plus something cubed. So let me go down to, well, maybe that one's not there. I'm going to change this first one to be the x cubed plus 8, right? Because we're going to notice that if it has a plus sign in between it, like this, and this 8 we can write as something cubed, and that something would be 2. So I'm really going to rewrite this as x cubed. So notice how I put it in parentheses there, and there's a reason why I'm writing it that way, plus, and then I'm saying, okay, what cubed is 8? And that would be 2. So 2 is going to go in my parentheses and cube it, right? And now this x and this 2 become my a and b in this. It's kind of like a little formula where I'm just substituting these numbers in place of it. So let me write down underneath here. So this is kind of like my a, and this is my b. Okay? And then if I'm thinking, that's why it's important to get this kind of memorized so that you can see this. So if I'm saying a plus b, well, in my case, it's x plus 2, right? Or my a and my b. So x plus 2 is going to go in my first parenthesis. Right? And then here, I need to take my a term and square it. So that is just an x, and if I square x, I get x squared. Then the middle term here is saying do the opposite, right, of a times b. So I've got to do minus my 2 times x, right, my a and b multiplied together. Doesn't matter if I do b times a or a times b, right, but I need to multiply these two numbers together. But we write that, usually the number first, so I'm going to write it as 2x. And then the last term is telling me to take whatever my b is and square it. So my b is 2, 2 squared is 4. And then that is my answer. And these sum and differences of cubes this trinomial cannot be factored any further, okay? And when a trinomial like this can't be factored any further, we call it prime. All right, so you might see that on some of the works that you're doing. If there's something that cannot be factored, then you're going to say, oh, that's prime. That cannot, be factored any further than that. Okay? All right, let me take questions on that one, because I know these are kind of a little bit weird if you haven't seen them before. So what questions can I take on that? Okay, and just so you know, I am going to try and, finish up. We're going to just kind of go until noon. And then if there's questions that you want to stick around and ask me individually, we can do that. Just because I have another class that starts after this one, so I just want to make sure that I can get your questions answered, but then make sure I'm on time for them as well. So, no questions there on that one? Okay, let's try one more. So I want you to try and do this. Notice how the difference of 2 cubes is just a little bit different than this. Let me put this in red here. So the difference of 2 cubes is saying a cubed minus b cubed. And then in the first parenthesis, instead of being connected by addition, it's connected by subtraction. So you're doing the a minus b. And then in the second parenthesis, you're doing a squared and then plus, instead of minus, plus ab and then plus b squared. Okay. Does that make sense? So now I want you to try one that is a difference of 2 cubes. Okay, so let's try this one. So what if you did x to the third minus 27. Okay, so that's not one of the ones on here, but let's do that. So everybody try and factor this. You're going to be using that blue one up there since it's connected by subtraction. You want to make sure you change it to that something cubed minus something cubed before you can figure out what your a and b are. Hey, Nikki, did you have a question?
Yeah, I'm sorry. I don't want to hold anybody else up.
No, you're good. I mean, people are working on it.
I'm confused on the previous problem. How did you get 2? Is that because...
The 2 here?
Yeah, like the 2 to the third.
Yeah, so what is 2 to the third power?
Is that because that totals 8?
Mm-hmm. Yep, so really on this one you're going to be kind of figuring out what times what is 27, right? To figure out what goes in place of RB there. Yep.
Is it 3?
Mm-hmm.
Okay, I'm done.
All right, somebody raise your hand and tell me what you got in the first parenthesis. Okay, let's just kind of break this down a little bit. What would go in the first parenthesis? Hey, Leah? Can't hear you, Leah. Did you have the... You still muted? Okay. Leah?
I got x minus 3.
Okay, so x minus 3 in that first one. Good.
Yeah, sorry, it wouldn't let me unmute.
Oh, that's weird. Okay, I know. So I just unmuted you because I was like, why isn't it working? I wonder if other people are having that problem. It's really weird. It shouldn't be, but I'll double check the settings on that. Okay, do you have what goes in the second parenthesis also?
Yeah, I had x squared minus 3x plus 9.
Exactly. All right, so on this first one, you just square that first number. The second term, you multiply those two numbers together. Whoops, it should be plus, right? Because you're doing the opposite of that. So plus 3x. Yep. And then take the 3 and square it on that. And that will give us 9. Okay, so that's one of the things that we're going to be, this is special factoring is what they call it. And so just if you have, something cubed plus something cubed or something cubed minus something cubed. Okay. And then there is something on here called perfect square trinomials. And I mean, some students find it helpful to be able to, see it, but other students are like, oh, I don't know, I can still just kind of do what I've done before. Meaning, like, if you were to look at this part A on there where it's saying, factor the x squared plus 6x plus 9, you really can just do what we were doing before. When the leading coefficient's 1, you're just asking yourself what times what is 9. That adds to be 6, right? And so x squared is found by doing x times x. What times what is 9 that adds to be 6? Well, that would be 3 and 3, right? And then this also could be written, since we have the same exact factor written twice, sometimes you'll see the answer written as x plus 3 all squared. And we talked about one like that before when we said, okay, if you had, if you're supposed to multiply this x plus 3 all squared out, right? We said, oh, we need to write it like this, with the x plus 3 times x plus 3, and then do the foiling. And then you'll come up with what we started with. And that's really what you want to kind of get to there. Okay? So I won't mark it wrong, either of these answers is perfectly good answers, but sometimes you're going to want to write it in this form. And I'll show you what I mean by that later in this chapter. I think it's in 7.4, so we won't get there today, but hopefully that can see that. Okay. All right, let's look at just maybe one more of these. So I want to look at this number 1 there. That one asks us to factor 9x squared minus 25. And so with this, you see these really big numbers and stuff, and rather than trying to, go, okay, I'm going to do 9 times negative 25, what multiplies to be those numbers, the adds to be 0 in the middle, that's just kind of a harder way to go about it. If you notice that both of these, right, we've got a perfect square here, and we've got a perfect square here. So we really have what we call a difference of squares. So I want to rewrite this out as something all squared minus something squared. All right, so if I'm thinking about this 9x squared, and I'm trying to think, what times what would give me 9x squared? Well, that would be 3x times 3x. So on this one, you can't just put the 3 in there or just the x. You've got this number out in front you've also got to kind of deal with. All right, so that breaks down to be 3x, because if I do 3x squared, well, 3 squared is 9, and x squared is x squared. All right, and then on the other one, what squared is 25? Well, that would be 5. And so on, again, something like this is like my a, and this is my b, and this is a difference of squares. So I said when I have something squared minus something squared, that's always going to factor to be, in this case, a plus b, a minus b. And so on this one, I end up with 3x plus 5, and then 3x minus 5. And it doesn't matter which factor I write first. I could have written 3x minus 5 and then 3x plus 5, right? But either way, it gives you your answer. So noticing that those are squared helps you to get this done faster rather than having to go through all of that work of, okay, what? 9 times 25 is what? And then trying to figure out what times what, you know, like, I mean, going back to what we talked about if the leading coefficient isn't 1. So just take a look and see, right, that there's perfect squares. Does everybody know what I mean by perfect squares? Or am I? Raise your hand if you want me to explain that further. Because perfect squares are like if you did, you know, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, right, and so on. So all of the numbers in this column, right, we call them perfect squares because if I take a number and multiply it by itself, I get these answers. Right, so 1, 4, 9, 16, 25, 36, right, 49, so on and on and on and on, right? All of those are perfect squares. So that's what I'm looking for here. I see 9 is a perfect square, 25 is a perfect square. And so that's how I know I can kind of factor it out this way. All right, take that little shortcut way. Okay, is there another question? All right, and like I said, this is just going to take some practice. You're going to have to, you know, kind of keep doing a lot of these. And I do have some other videos and stuff that are there by the assignments as well. And so you might want to look through some of those. Those could be really helpful as well if you're kind of feeling stuck and going, okay, how do I do this again? What do I need to do? Okay. So I want to go to our notebook again, if I can get this to pull up. Where did it go? Too many things opened. Okay, so let's go to 7.3, and we'll talk about a few things on here also, but it's not letting me write right on here now. I'm going to have to figure that out later. I just don't want to take class time to do that, so I'll just write some of the stuff over here that corresponds with our notebook. The first, question is asking, why might you want to solve a quadratic equation to graph a quadratic function? So think back, to what we talked about up here, right? Remember how at the end of last time we were like, oh, okay, we've got this in this form. This isn't in a factored form. And so it's a little bit harder to tell what the x-intercept is, what the y-intercept is, what the vertex is. So when it's written in this form, we can easily pick out some other, some important parts of that graph. Remember that graphs of quadratics are called parabolas, so I'll use that term parabola a lot. So we can find the vertex of the parabola, we can find where it intersects the x-axis, and so that's why we'd want to be able to solve it, because when we solve it, we're actually, you know, figuring out, well, where are those x-intercepts? Where is it crossing the x-axis? So on this 7.9, right, it's just asking a question. Is x equal 4 a solution to this? So how would we decide if x equals 4 is a solution? Somebody just unmute yourself and tell me what you think there. How do we know if it's a solution to this? How could we figure that out?
Can't we just sub the 4 in for x?
Yeah, right, saying x equals 4. So with substitution, that's just saying, yeah, we can take this, put it in place of x, where both of the x's are, and then see if it comes out to be the answer or not. Whoops, that should have been a minus there. Make sure I put kind of a minus there. So then if I put that in, right, I'd get 4 squared plus 4 times 4, and then minus 4. Does that equal 0? Right, so we're trying to ask, is this a solution to this? So I've got 16 plus 16 minus 4. Does that equal 0? Not in my book, right? That doesn't look like that's going to work out there. Right, I got 32 minus 4 on this. So this does not equal 0. So it's not true. So that means that this x equals 4 is not a solution. All right, so you can always plug them in, right? Like we said, to figure out if it's a solution or not. Okay, so that'll be sometimes it'll ask you to do it that way. But then it might also ask you, like on the 7.10, for you to actually solve these equations. So sometimes they'll be written in factored form for you already, like these are on here. So on the part A, whoops. So on part A, we got x minus, goodness. So x minus 6 and then 2x minus 1 equals 0. So I want you to think about this for a second, just because, I mean, I can tell you how to do this, but sometimes students get lost in like, why are we doing this? But think about if we have something, right, something times something equals 0. Well, doesn't that mean that either one or both of these factors has to equal 0? We can only get 0 if we have like 0 times some number, or if we do 0 times 0, right, equals 0. So that is really what we're doing on this, is we're going to take each of these parts, right, we're saying this factor, this x minus 6 times the 2x minus 1 has to equal 0. So we're going to set both of those parts equal to 0. So I'm going to say x minus 6 equals 0, and then 2x minus 1 equals 0. And then I'm going to just solve them like we did, right, when we talked about lines. These are now linear to linear equations. So I'm going to add the 6 over. So I get x equals 6 is one of my answers. And then here I'm going to add the 1 over, and then divide by 2. So x also equals 1/2. Right? And so these things that we just found when we're setting these equal to 0 and solving them, we just found the x-intercepts. So this is where the parabola is going to cross the x-axis. So if I was to make just a little rough sketch of this, right? So let's see, 1, 2, 3, 4, 5, 6. So I know this is saying that it's going to cross at 6 there, and it's also going to cross at half. So I'll put it in between there. And since it's a positive one, I know it's a right side up parabola. And like I said, this is just a rough sketch. I don't know how far down this goes, right? But I know it's a parabola that's going to go through those two x-intercepts, right? So the parabola will go down so far and then come back up, okay? And parabola should be symmetrical, so mine is not looking super fantastic there. Right? But I just want to make sure it's clear. What are we finding when we're solving these equations? Right? Solving these quadratics. That's what we're finding. Okay? So now do part B and part C on there. Try solving part B and part C. Okay, so hopefully you set both of those factors equal to 0. I put this one in, all in parentheses to maybe make sure it's a little bit more clear, but that doesn't have to be in parentheses, but it's still connected by multiplication, and that is the important thing to make sure you remember here. So we're putting both of those things equal to 0, so I'll subtract the 3 over, and then I'll divide by 12. So I get x equals negative 1/4, if I reduce that. And then on this one, right, if I divide by 4 on both sides, right, 0 divided by anything is still just 0. So here I get x equals 0. So my two x-intercepts this time would be at negative 1/4 and positive 0. Or positive 0, just 0. Okay. All right, but part C is a little bit different because notice how it doesn't equal 0 here. But we've got to make it equal 0. We cannot solve these unless it's equal to 0 because remember, the only thing that we know for certain is if this is equal to 0, then one or both of these factors has to be 0. So we're trying to figure out what makes those 0. Okay, we can't do that if this is a 12 here. So we're going to need to move that 12 over to the other side, and then we're going to have to combine it together with the like terms, but that means we're going to have to FOIL this out first. Okay, so if we start by FOILing this, we'll have x times x is x squared, and then x times 2 is 2x, and then we got negative 2x, and then we have negative 4, right, equals 12. Well, my middle terms, right, just cancel out because 2x minus 2x just gives me 0, so those are gone. And then I'm going to subtract my 12 over to the other side so I can get one side of the equation equal to 0. I've got to have it equal to 0 to do anything more with this, to solve it. So x squared minus 16 equals 0. Okay, what questions do you have up to that point? So we have to have our, it equal to 0. So we're going to have to subtract that 12 over. And then from here, right, then we're going to have to factor that to go any further. So we had to FOIL it, move that over, and then we're going to have to put it back in factored form, right? And we already did this one earlier. We said what times what is x squared? That's x and x. What times what is negative 16? That adds to be 0, because remember our middle term is 0. And so we said that was negative 4 and positive 4. Right? And now I can set each part equal to 0. So I have x minus 4 equals 0 and x plus 4 equals 0. And then solve each of those for x. So here I'll add the 4 over. X equals 4. Subtract the 4 over. So x equals negative 4. So those would be my answers on that. And I can always, remember on anything that says solve, which these are saying, I could always check my answers, put them back in to the original question to see if that worked out, right? So if I check it over here, if I put my 4 in place of my x, right, 4 minus 2 is 2, and then 4 plus 2 is 6, right, and do those equal 12? Yep, because it's connected by multiplication, so 12 equals 12. So that checks out. And the same thing would happen if you tried out that negative 4. Put those both in place of x and check it out. All right, so you can always do that with any solving problems, which I like, because you don't have to, guess or, is this answer right or not, right? Because you can tell for sure that it is correct if you do your checking on that. All right, what questions can I help you with or answer on this? You guys are being so quiet and I cannot see your faces. I cannot tell what's going on over there. So you've really got to speak up and talk to me so I can help you. If you just stay quiet, then I can't help you. Okay, Nikki.
Sorry.
Why are you sorry? I bet everybody has these same questions. They're just not asking, so please ask.
I don't know. When you're checking your answer, you have 2 x equals 12. Where did the 6 come from? Am I not seeing it somewhere?
So I'm putting the 4 in place of the x. So 4 plus 2 gives me that 6.
Okay.
Right? And then to get the other one, right, I'm doing 4 minus 2 gives me the 2.
Got it. Okay. That's fine.
Yep. Other questions on this? Okay, I want to kind of skip down a little bit here. So let's try this. Everybody do part A and part B on this next page there. And then when you have an answer, right, what x equals on both of those, please raise your hand so we can. I really can't tell where you guys are at unless you're telling me.
Are we solving?
Yes, please try and solve those. Right, so set each part equal to 0 and then solve each of those for x.
On both 713 and 714?
So just 713.
Okay.
Right, part A and B.
Thank you.
Yep. please raise your hand when you get these done. Actually, just raise your hand when you get part A done. Maybe let's just start there so I can see who's done with part A. Okay. Haley, would you mind telling me what you did to solve part A?
So I set both of those factors equal to 0.
Okay, so you did 2x plus 3 equals 0, and then 10 minus x equals 0. Okay, and then what? From
And
this
then
first.
subtracted 3.
Mm-hmm.
And then divide 2. So x equals negative 3 over 2.
Okay. So
And
there.
then I subtracted the 10.
Okay. So you got negative x equals negative 10.
Yep. And then divided by the negative 1.
So
And
x.
x equals 10.
Okay, awesome. Check and see if that's what you all got on that, on part A. Right, so x equals negative 3 halves and x equals positive 10. So you should have there. If you didn't, check and see. On the second one here, it's really easy for people to forget that they need to divide by that negative 1 if they subtracted that 10 over. You could have added the x over instead, and that still would give you x equals 10. So you could have gotten there a different way, but still you would get x equals 10. Okay, what about on part B? This one, as you started it, you may have been like, it's a little bit different. Rebecca, did you get through that one? I thought I saw your hand up first when I had those.
Oh, no, I was just putting my hand up to show you I was done.
Okay, so can you tell me how you would start this one out?
So I just set each term equal to 0 like we did before.
Okay. And then what did you
solve for x?
Okay. And you could have, did you add the 3 over and then divide by 3?
Right.
Is that what you did here? Okay. Because you could have factored it first, but for most students, it's just faster to go this way. Meaning I could have factored this, to be 4, like that greatest common factor there is 4. So 4 parentheses x plus 4. And go from there. But I think for most students, it's just easier just to solve like we have done, problems before we even did any factoring.
Right, and those were pretty straightforward, so I didn't do the work or whatever.
Yeah. So you could have, like I said, factored it, but you didn't have to on these ones. But what I wanted, make sure everybody checks and see. Make sure these are what the answers were that you came up with there. If so, then you're doing it right? But if not, let me know if there's something I can clarify there. Because on this next one, right, the 7.14, on this one, you can't, you actually have to do some factoring on this to be able to solve it. So let's look at this one next. So if I have, right, it wants me to solve x squared plus 5x plus 6 equals 0. So the only way I can solve these quadratics is I need to factor them. So that's like one of the reasons why factoring is such a big deal and something that we need to make sure that we know how to do, because we can't solve quadratics. And even when you get, like those of you that are, well, most of you are going on to 1050 after this class, you'll see that you're going to be needing it for, you know, ones that are an x cubed or an x fourth or whatever. So factoring becomes a really important part of what you're doing, because you can't just move these things over because we've got this x squared, right? Not just an x like we had on these. So this had to be broken down into factored pieces first. And so this one, we need to start from the beginning and figure out, okay, how can I break this down into my factored pieces so that now I can set both parts equal to 0 and solve it. All right, so again, since our leading coefficient is 1, we're just going to ask ourselves what times what is 6? That adds to be 5. So 3 and 2 multiply to be 6, and if I add them together, I get 5. Right? And then I can set each of those parts equal to 0 to solve it. There. Okay, and sometimes, you know, you can just kind of see this without doing all that work there, but I would just want to make sure everybody's seeing where I'm coming up with those numbers. So our answers are x equals -2 and x equals -3. And again, remember, if I was, you know, graphing this, you know, these are my x-intercepts. Oops. So this is where it's crossing the x-axis. So let's see, I'm going to kind of try and spread this out a little bit so you can see. So here's -2, here's -3, and my leading coefficient was positive, so I know it's a right side up parabola. So just a rough sketch of this is going to go down through -3 and then back up through -2. So it would be a parabola that looks something like that, right? And sometimes all we care about is what the kind of the shape of it is, what it kind of looks like. Other times we need to know how far this goes down and where that vertex is. But when we're just writing a rough graph of this, all right, we can just say, okay, we know it's going through these 2 points. So that's what's happening here. Okay, so try this. I want you to try, let's do A, B, and C on that next page. All right, so you need to factor each of those and then set them equal to 0 to solve them. So work on part A first. Okay, when you get that one done, raise your hand so I can see where people are at. Okay, so you're going to factor this first and then set each part equal to 0. If you're done with part A, please raise your hand so I know. If you're stuck somewhere, like, unmute your mic and ask your question. Okay, Charlie, I'm going to ask you, what did you get? What multiplies to be 12 that adds to be 8?
I got 6 and 2.
Okay, so positive 6 and positive 2. Okay, and then what did you do from there to solve it?
I just set them.
Okay, set both equal to 0. Right, and some of them, when they're easy like this, you can kind of see, oh yeah, it's really just the opposite, right? Because I'm subtracting that 6 over, and I'm subtracting the 2 over. So you should get x equals negative 2 and x equals negative 6. Okay. All right, I'm going to put your hands down now, and let's look at part B. So on this one, again, we need to have everything on one side, like this was, so that the other side could be equal to 0. So we've got to move, these things, and we want to keep that leading coefficient positive where we can, because it's going to make our factoring easier. So I would suggest on this to subtract the 10x over to the left side and add the 25 over. Okay, and so let me do that on here. So I'm going to subtract the 10x over, and then I'm also going to add the 25 over. All right, so what I really get there, let me rewrite this down. So I've got x squared minus 10x plus 25, and then there's nothing left on this side, right? I was moving it over so that I could put this equal to 0, because remember, I need it equal to 0 so that I can do that 0 property rule where I can set each factor equal to 0. Okay, and then from here, I need to factor these. All right, so I'm thinking what times what is 25, right? So what multiplies to be 25, but adds to be negative 10. All right, so we have to make sure everything's moved over to one side before we start thinking about, what multiplies to be 25 adds to be negative 10. Okay, and what would that be?
Would it be negative 5 on both?
So negative 5 and negative 5?
Yeah.
Yeah. So we're going to have x minus 5 and x minus 5. Right? Because negative 5 times negative 5 gives us a positive 25. And when we add them together, we get negative 10. Awesome. And then when we set each of those equal to 0, right, we end up getting a repeated answer, right? We get the same thing because those are the same factors. And so what do we get there? Oops.
5. Positive 5, right?
So positive 5. Right, and you only have to write it down once. Just because it shows up, twice here, that doesn't mean that you're writing the answer down twice. Because what's happening here, sometimes people go, what in the world is happening here? Because if I'm thinking of my graph, like we were talking about before with this is saying my x-intercept is at 5. So 1, 2, 3, 4, 5, right? And there's only one of them. So that means it must be either a right side up parabola coming up at that point or an upside down parabola. But again, since my leading coefficient was positive, I know that's going to be a right side up parabola. It touches at 5 and then turns back around. Okay, so that's what happens when we have a repeated, those repeated x-intercepts. Right? It's just a turnaround point on this. Okay, everybody try C now. All right, I would encourage you to add the 3x squared over to the other side because it's easier if you have that leading coefficient being positive. And then this is where you're going to be using some of those things that I talked about when the leading coefficient isn't 1, how you can solve those. So maybe you're going to try and do the box method or something like that. Okay, so let me give you a couple minutes to think what you would do there. Okay, again, raise your hand when you have part C done so I can see how you're doing. This is going to be... Okay, well, we're kind of running out of time here, so maybe let me just work through this one. So where you're at, just maybe just look over here and see. So first thing we want to do, right, we want to get everything over to one side, so we need to add that 3x over, or 3x squared. So I have 3x squared plus 5x plus 2 equals 0. And then remember, when my leading coefficient isn't 1, I need to multiply, right? So I'm doing the 3 times the 2. So 3 times 2 is 6, so I'm thinking to myself, what multiplies to be 6 that adds to be 5, right? And so what do you guys think that is? Multiplies to be 6, adds to be 5.
3 and 2?
Yeah, 3 and 2. Right, the only things that it could be. So remember, then you need to write this out as a 4-term, and this is where some people get confused on it, so that's why I want to make sure it's clear. So after you figure out what these are, remember this becomes, you're like splitting this up to make it into a 4-term polynomial. So I have my 3x squared, my 5x breaks down to be the 3x and the 2x, so plus 3x plus 2x, and then I still have that plus 2. And then from here, you could either do the box method, the synthetic factoring, the factor by grouping, right? But if you do the box method, we're just putting these 4 numbers in the box. So 3x squared, 3x, 2x, and 2. And then remember, I'm going, looking on the rows to see what will that's common, and then on the columns to see what is common. So let me look at, so this one first. Right, so 3x squared and 3x, their greatest common factor is a 3x. Right, and then 2x and 2, their greatest common factor is a 2, and it's a positive 2. So I'm going to put a plus sign in between there. All right, then let's do our columns now. right? So if I have 3x squared and 2x, well, the numbers don't have anything in common, but I do have an x that's the same that could come out, right? And then this one doesn't have anything in common with each other, except there's really like a 1. You know, you can always say, you know, 1 is a common factor there. So that's what we have to do on this one. So there's, you know, not a 3, not a 2, not an x that's in common. So the greatest common factor, the only thing we can divide out of both of those is a positive 1. So that means that factors to be 3x plus 2 times x plus 1. And now we'll set that equal to 0. I should have left that equal to 0 there. All right, and now I can take each of those two different parts, 3x plus 2 equals 0, and x plus 1 equals 0, and figure out what x is here. So if I subtract the 2 over, and then divide by 3, I get x is negative 2/3. And this one I just need to subtract the 1 over, so x equals negative 1. Okay. Raise your hand if you were able to come up with that. I know some of you may not have got quite there, but let me see who was able to get there, because there's a few of you at least. Okay, what questions did you have? Like, was there a spot in which you got stuck that you weren't quite sure what to do? So go ahead and just unmute yourself and ask your question. So I can answer that for you. There's a place you got stuck that I can clarify. No? This is so weird for me. I can't see you guys. I can't hear anything from you. I feel like I'm talking to myself. This is not good. I just don't like it. But it just makes it hard for me to tell what's going on with you. Okay, well, we're going to stop there today. So I want you to try, and you should be able to work on those factoring assignments in 7.2 and also the Adfinity on 7.3, right? But remember, the first thing you should get done is that test. That exam 2 is due tonight by midnight. And then the car comparison project, you say, is due tonight, but I'm giving you kind of an extension. You can turn it in until April 2nd. So you have a couple of days to work on that. And then this stuff won't be due for a couple of weeks, but I'd like you to try and get started on this, because the next thing we talk about on Thursday is going to build on all of this. So if you're struggling with the factoring, it's going to kind of slow you down in the next things that we're figuring out. So before we meet on Thursday, please try and get some of the at least 7.2 done where you're doing the factoring. Okay. What other questions do you have?
I just have a quick question.
Yeah.
On just this last problem that we just barely did on C.
Yeah.
So 3x, your first parentheses.
Mm-hmm.
Wouldn't it be 3x plus, wouldn't that reduce down to 3x plus 1? Then 3x squared plus 3x in the first parentheses, and then 2x plus 2.
I don't see what you're talking about.
So, like, I did the equation, like, not with the box method, but with the other method, the first method that you taught us.
Okay.
And,
so if we do that, so let me try and do that underneath here. So if we have, so you took the 3x squared plus 3x plus 2x plus 2 and then did the little dividing there.
Yeah, and then just divided it.
Okay, so when you do this, right, so 3x is what is what you can take out, but then what's left over?
No, it's okay.
So when you do 3x squared divided by 3x, there's an x left, and 3x divided by 3x gives you 1.
Oh, right.
Right?
The x plus 1, yeah.
Yeah, and so then over on the next side, so 2 and 2 is our, so positive 2 can divide out of that. And again, you're dividing those. So when you're dividing those out, you're left with x plus 1 also. So then remember that this is your greatest common factor now. So x plus 1 goes in one parenthesis, and then your leftovers go in your other parenthesis.
Oh. Okay.
Okay, so you may have just been getting confused about like the different methods and stuff like that. And that's why I say like sometimes it's just easiest like stick to, you know, find a method that works for you. And this is a great one. A lot of people really like this one. But at this point you need to remember, oh yeah, I've got a greatest common factor that factors out. And then the stuff on the outside is my leftovers that goes in my other one. Okay, that's a good question. 'Cause that's okay. We're still learning. I'm sure you're not the only one too, right? I mean, so good. I'm glad you asked that question. I bet you clarified things for a lot of people you don't even realize. So, okay. All right. Well, we'll stop there. If you have any individual questions, you can stay on for a couple minutes. I do need to get off though in about 5 minutes. So if you have a few things you want to ask me, please stick around and I can take some of your questions, okay? Otherwise, remember that Mondays, right? Monday mornings, I asked you about that online office hour from 11 to 11:50. It's on Mondays and Wednesdays, so I have it tomorrow as well. So if you can come to that to get some extra help on this, that would be the greatest time to come get help from me on that, okay? And it would just be in my personal room. So if you have questions on that, just email me, okay? All right, have a super day, guys. We'll see you on Thursday.
Thank you.
Yep, bye. Okay, is there any of you that have some individual questions that you want to ask about?
I have a quick question. It's not homework related.
Okay.
With the car comparison and everything, the PDF.
Mm-hmm.
With the PDF, I know there's a link on the Canvas page, but do we send you pictures before we do add it all on there, or what do we do with it? I forgot.
So you're going to take pictures of it and change it to a PDF, and then you'll upload that PDF file to where our assignment is on the car comparison project. So you're not putting anything on the e-portfolio yet. Is that what you were thinking, that you were going to be putting on the e-portfolio, or no?
Not the portfolio. I know that we were not supposed to do it. So do we PDF it and then submit it to the wherever you set the car comparison and submit it, and then you look at it before we submit it?
So you look at it, or yeah, you submit it, and then I'll look at it. I'll write feedback right on there that you can look at. So when you click on, like in the grade book, and there'll be like some like feedback and stuff like that button. So you can click there, and then you can see all the feedback that I give you on it and what things you need to change. And then you'll keep redoing it until you get it all correct. Does that make sense? So if I tell you that there's any changes that need to be done, then you'll make those changes, resubmit it again to me so I can look and see if it's all, good now. And if there's anything else, then I'll tell you. Because I need you to keep redoing it until it's right, because this is going to be going on your e-portfolio. So,
yeah.
So does that make sense, or?
Yeah, is that the same thing we do with our test, just PDF and then email to you?
Not email it. So on your homework, like, so when you're going in, there's a place on the exam number 2 where you can submit it. So if you just, even on the home page, you'll see like the calendar off to the side, it gives you the due dates. If you just click on that, it'll take you into that assignment, and then there'll be a button on there that says submit assignment. You'll click that, upload it, and then submit it. Have you done that for other classes or no?
No, you're the only one that I've done it so far for.
Okay. Well, reach out to me maybe a little bit later or something, and I can help you, if you're getting stuck on it and stuff. I'm more than happy to. And even, let me just, write this down. And Brandon, I know you had some questions about this too. So this is my phone number. Just text me first, and just say, would now be a good time. I'm going to be teaching until 2:30 or maybe a little bit longer today. But write down my number. I don't mind if you call me, text me and stuff, because it might be easier for me to kind of work through it with you as you're actually submitting it. Does that make sense?
Download Canvas onto your phone.
Uh-huh.
There's a Canvas app. I don't know. It's new to me, but submitting things through with PDF after you do like Adobe a scan or whatever is way
so much easier. Yeah.
You just grab the subject and then just like that, like say math, and then all of your due assignments will pop up, and you just grab it and submit it, and that's it. No, I'm not finished.
So, I know, this is so hard. It's so stressful. So, Monica, do you have that? Did you download the Canvas app yet?
I have it on my phone, so that should be good.
Okay.
I barely scan the car comparison on Adobe, so I just go to Canvas and then it'll.
Yeah. So just go in there. If you want me to like talk you through it and stuff in a little bit, I can do that. But like I said, right now I've got to get over to my other class and stuff, but I want to make sure you know. So take down my number. I really don't mind if you just text me, call me, let me know if, like just say, Becky, is this a good time? Can I call you so I can get it submitted? And as long as it's after like 3, it would be probably good for me today. Okay.
Sounds good.
And same for you, Brandon. Does that sound good? Do you have the Canvas app downloaded on your phone? Okay. Yeah, it's going to be so much easier just getting those since they're already on your phone, right? And because you're going to be taking pictures with your phone, and then you're going to be saving them on your phone as a PDF, then you can just grab that file and submit it right to Canvas. It's so much more slick that way. I'm glad Nikki said that. So, all right, guys, we'll see you on Thursday. Or if you have questions, please, come tomorrow morning to my office hours between 11 and 12. Okay? Okay. Awesome. See ya. Have a good day. Bye.